I've been working as a data scientist now for about 3 years, and in this video I want to give you a breakdown of the exact roadmap I would follow if I was learning data science completely from scratch again. Let's get into it. Data science is all about breaking down problems and doing deep analysis and building machine learning models, and maths is the bedrock behind all these things. Fortunately, the maths needed for data science is not like PhD or master's level. A lot of the maths is taught in the later years of high school, so it's pretty accessible to most people. In general, there are 3 areas of maths you should know: calculus, probability and statistics, and linear algebra. Probability and statistics is probably the most important and is the one I use most day to day, so this is the one I would really focus your efforts into. To start, I would recommend learning things about descriptive statistics, things like mean, mode, standard deviation, median, anything that summarizes data. And I would also learn things about plots, so how to visualize data using bar charts, graphs, violin plots. Just visualizing and summarizing data is the first step. Then I would learn common probability distributions like Poisson, gamma, binomial, and normal. After that, it's time to learn some probability theory, so things like central limit theorem, maximum likelihood estimation, and Bayesian regression. These are used so much in data science, so really make sure you understand these. After that, you should really learn hypothesis testing and confidence intervals. A/B tests are pretty much how any company nowadays tests a feature they're going to release. And A/B tests, under the hood, are just a form of hypothesis testing. So things like t-test, z-test, chi-square test are really things you should learn because they're used extensively in pretty much every company. And finally, I would learn things about modeling and inference. Even though this kind of crosses over with machine learning, but there are 2 models, linear regression and logistic regression, which are more statistical models than they are machine learning models, so I'll definitely learn these. To learn all of this, I recommend the textbook Practical Statistics for Data Science, because it's in the title, it's mainly designed for data scientists, and it also has code examples, so you can also practice your statistics whilst also brushing up on your Python skills. After you've learned stats, I will then move on to learning some calculus. Calculus is like the lifeblood of how machine learning algorithms actually learn. Think gradient descent for linear regression or backpropagation for neural networks. The reason these algorithms work is through calculus, so it's a must know for any data scientist. I would learn things like what is a derivative, what are the common derivatives of functions like sine, cosine, the exponential, partial derivatives and multivariable calculus, Jacobian matrices and Hessian matrices, turning points, stationary points, product rule, chain rule. All these things around how you basically calculate differentiation and also integration are really important to know. To learn all this calculus, I recommend the textbook Mathematics for Machine Learning. To be honest, it's probably a bit too advanced, but it'll cover all the basics. So just skip to the sections where those things are covered and don't worry about the rest. Of course, you can dive deeper if you're really interested, and that'll make your calculus knowledge very excellent. And finally, the last topic is linear algebra, which is all about how linear transformations affect vectors and matrices. Now, you may think this is not used that much, but it's actually used quite a lot. For example, TensorFlow, which is like one of the best packages out there for neural networks. Tensor is actually a matrix, and data frames, where you store your data in training, validation, and testing sets, are actually just a multidimensional matrix. So matrices and vectors are literally everywhere in data science. The things you should know are what are vectors, what is the magnitude of a vector, what is its direction. Then things like matrices, the inverse, transpose, trace, eigenvalues, eigenvectors. These are things that are so important and crop up all the time. And finally, you should be familiar with systems of linear equations. These are used quite a bit in optimization problems, and naturally, sometime in your data science career, you will have an optimization problem to solve, and these come in real handy when that's the case. To learn all of these things, I recommend the Linear Algebra for Machine Learning course on Coursera. Again, it's excellent and is specifically designed for data scientists and machine learning. After you've logged down the maths, it's now time to develop your coding skills. I'm sure by now you know the 2 main languages for data science are Python and SQL, with Python probably being the more important one. For Python, I recommend taking any introductory course. I will link on screen here some recommendations. In reality, it doesn't matter which course you take because any beginner course will teach you the exact same things. The main thing is just to pick one and get started. On the screen here are the things you should learn. And the main thing I want to drive home is that make sure you do the exercise problems. You only really learn programming when you have hands-on experience. Watching a video of how to write a function is not quite the same as actually writing a function. So make sure you do all the exercise problems and get hands-on experience. After you've developed your Python skills, it's now time to learn some SQL. On screen here are again some recommendation courses I suggest you take. Again, doesn't matter which course you take, just as long as you pick one and get started. In terms of what you should learn, on screen here are all the basic functions. These basic functions are pretty much what I use 95% of the time when I'm doing any form of SQL. If you have time, I also recommend investing some effort into other tools and technologies that are used frequently by data scientists. These are Git, Shell and Bash, and also a package manager like Anaconda. I'll link on screen here some really good tutorials to cover all these things and also in the description below. Right, at this point we have developed all our fundamental knowledge in programming and maths to start getting into the fun bits, which is actually learning data science and machine learning. To start, I recommend learning the Python specific libraries for data science and machine learning. The things you should learn are NumPy, which is like a scientific computing package, Pandas for data manipulation, scikit-learn for the baseline machine learning algorithms, and matplotlib, which is a plotting library inside Python. The next step is to delve into some machine learning theory. By far and away, the best machine learning course is Andrew Ng's Machine Learning Specialization. I took this back in 2020 and it is amazing. I mean, back in 2020, it was written in Octave, but now it's been revamped, it's in Python, and it even has more cutting edge algorithms in there, like recommendation systems and reinforcement learning. So I really recommend you start with this course. After you've completed that course, I recommend you take on the subsequent one, which is the Deep Learning Specialization. This will teach you things like RNNs, CNNs, and will even touch upon large language models. So this will teach you all like the cutting edge aspects of current machine learning. With all that new knowledge under our belts, it's now time for the most important step, which is projects. This is how you're going to solidify all your knowledge in Python, SQL, maths, machine learning, because getting hands-on experience practicing these things is by far and away the best way to learn. Some ideas to try are entering a Kaggle competition, implementing a machine learning algorithm completely from scratch, or any other personal projects that really interest you. The point is, just do a range of projects in different areas, and that's the way you will learn. Try out different algorithms, different business cases, different types of problems, because the more breadth you get, the better your skills will become. Before applying to any entry-level roles, I recommend you do some extra work to ensure that your CV and application really stand out. Nowadays, loads of people want to be a data scientist, and the market is quite tough at the moment. So you have to do that little bit extra to make sure that you stand out from the crowd. Some things I recommend you do is get a GitHub profile and populate it, implement a research paper from scratch, write a blog post about anything you've learned, studied, or are learning, and finally, create a personal website with all the things you're learning, done, your progress, just to showcase your interest in the field. I promise that 80% of people probably won't have this, so you immediately be in that top 20% of applicants. And not to mention, doing all these things will demonstrate your interest, improve your coding skills, and make you a better, well-rounded data scientist. Now we are at the final stage, which is job applications. And to be honest, this is probably the hardest, mainly because there's a big element of luck involved in landing any job. To improve your luck, make sure you do those things that I mentioned to stand out. But ultimately, it does come down to a numbers game. I'm not lying when I say that I applied to over 300 jobs when I was trying to land a graduate data scientist role. I mean, not all of them were data science roles, but majority of them were. So this goes to show you that it is just about volume. Some people may disagree with this approach and say that you should tailor your CV and application to each job. I mean, this is probably true, But to be honest, sometimes you just don't have the time to do this, and sometimes it's really not worth the effort. I'm not saying just spam apply for every single thing you see. Make sure you review the company and the job to make sure it's somewhere you'd like to work and a job is something you'd like to do. Otherwise, you're kind of wasting your time and their time. And don't worry if your first job is not at a FANG, hedge fund, or some really sophisticated fancy company out there. The goal of your first role is just to learn as much as possible and become a better data scientist. You can always change careers and maneuver your kind of trajectory later on. If you want more tips and advice on how to break into data science, then make sure you check out my weekly newsletter, Dishing the Data. I send it every Monday morning, and it's all about my thoughts and experiences as a practicing data scientist. If that sounds interesting, I'll link it in the description below for you to check out. If you enjoyed this video, make sure you click the like and subscribe button, and I'll see you next time.